Hi, in this video, I'm going to talk about graphing parabolas when those parabolas are in two forms. So in both cases, we're going to focus on when the x is being squared. So we have something like y equals ax squared plus bx plus c. Sometimes you'll also see this with function notation. So it might look sort of like that. Let me erase that. Where f of x is equal to ax squared plus bx plus c. So let's take a particular example here. Let's suppose we have the parabola y equals 2x squared minus 4x plus 5. And we want to graph that parabola. So over here, we've got some steps to help us through that. So just first, the basic shape it's going to have, I'll just draw a very rough sketch and then I'll get to the details. It's going to look sort of like this, like it's going to be almost like a U shape kind of thing, but we need to figure out exactly where that U is positioned and that sort of thing. So to do that, one key thing we want to find is the vertex. So that's the point where the parabola symmetrically opens either up or opens down. So we want to find that vertex. And in this case, when it's in this form, one way to do that is to find that the x coordinate is at the point negative b over 2a. So here that means it's at negative 4 over 2 times 2. So our a in this equation is 2, b is equal to negative 4. So now we can simplify this. So negative 4 is 4 divided by 4, which is 1. So we know that the x coordinate of our vertex is going to be at 1 in this case. Um, and then we're going to substitute that in to figure out what the y is. So I'm just going to circle that so we know our x. To find the y coordinate, we're going to put that into the equation. So we know that y has to equal 2 times x squared minus 4 times 1 plus 5. So that's going to be 2 times 1 minus 4 plus 5. 2 minus 4 plus 5 is going to give us negative 2 plus 5, which is equal to 3. So the y coordinate is 3, so our vertex is going to be at 1 comma 3. So I'm going to go ahead and sketch a graph and just put that vertex on there so we can see what that looks like. So if I make this a little bit bigger, um, so I need to go over 1, up 3, and that's going to be the vertex. The next thing I can do is I can look at the a in the equation, which a is equal to 2. If it's positive, our parabola is going to open up. So I know that my parabola is going to be one sort of like that. But to get a better sense of how steep the sides are, things like that, I can find 2 or 3 other points on the parabola. Just a hint so we don't wind up with super big or super small values. If we choose x's close to the vertex, that's going to make it, a more reasonable to fit on the graph. So our vertex is at 1. So I'm going to see what happens if I do x equals 2 and x equals 3, just getting a little bit bigger, a little larger than the point 1. And I'm going back to this original equation, y equals 2x squared minus 4x plus 5. I'm just going to write that over here. So if x is equal to 2, y is going to be 2 times 2 squared minus 4 times 2 plus 5. So this is 2 times 4 minus 8 plus 5. 8 minus 8 plus 5 is equal to 5. So this gives us the point 2 comma 5. So we can go ahead and just put that on now. So over 2 up 5. And then when x is equal to 3, y is going to be 2 times 3 squared minus 4 times 3 plus 5. So this is 2 times 9 minus 12 plus 5. So I've got 18 minus 12 plus 5. 6 plus 5 is 11. So I now also have the point 3 comma 11. So I'm going to have to go a little bit high here, but here's my 3. I was already at 5, 6, 7, 8, 9, 10, 11. So that point's going to go approximately there. So from my vertex, I'm opening up So just sort of connecting these points. There's going to also be symmetry here. So if I know this point was at 5, this one's also going to be at 5, and this one's going to be at 11. So I can kind of use that to help me get a sense of how the other side goes. And again, this would be perfectly symmetrical, but that's kind of a rough sketch of what that graph is going to look like. So this is showing the graph of this parabola, of this quadratic equation. Um, that's one way to do it if the equation's in that form, using that negative b over 2a to find the x coordinate. Sometimes instead, you might be given an equation that looks like this. If we have something like y is equal to negative x plus 1 squared minus 2. So we still have the key idea that x is being squared for the parabola and y is just regular y. But in this case, we can find the vertex. So this comes from the form y equals a x minus h squared plus k. And in this case, the vertex is going to be at h comma k. So we don't have to do a calculation to find the vertex. We can pick it out from the equation. A still has the same meaning as the A above. So for this parabola, our vertex is going to be at h, which because this has a minus sign here, we're doing the opposite sign. So h is going to be -1, k is -2. So our vertex is at the point -1, -2. Um, And then we're going to go ahead with the steps above here. So we're going to follow, we found the vertex. We're going to determine if the parabola opens up or down, and then find a couple other points on the parabola. So let me just start sketching that out quickly. So we have our axes sort of like this. We have a vertex at -1, -2. In this case, our A is, let me pull this down a little bit. A is right here. A is -1. So this parabola will open down. So again, good to keep in mind, just because then when we find points, if we don't see that happening, we know that something must have gone wrong. So if we have, I'm just going to go with x equals 0 and see what that gives us. And then I'll also do x equals 1, because again, I'm choosing points close to my vertex. So x is 0, y is going to be -0 plus 1 squared minus 2. Remember, work in the parentheses first. So we've got 1. We're going to square that. So this is going to be -1 minus 2, which is -3. So we have the point 0, -3. And let's get another one. If we do x equals 1, y is going to be -1 plus 1 squared minus 2. So this is going to be -2 squared, which is equal to -4 minus 2, which is -6. So we're going to have another point at 1, -6. So we've got 0, -3, 1, -6. And sure enough, this looks like a parabola that's opening down from our vertex. We can take advantage of that symmetry and know that we'd also have a point right here and right here. Again, not perfect with my drawing, but something like that, opening down. And that gives us a good sense of what this parabola is going to look like. So those are two main ways. If it's in this vertex form right away, we can pick out the vertex and then we still find a few other points. If it's in the form ax squared plus bx plus c, then we use this formula to find the vertex. So that is it. Thank you very much.